Hey everyone, my name is Dr. Megan Dooley and I'm an occupational therapist, and I'm here to talk to you today about Brain Injury Awareness Month, which is the month of March, and I'm joining the movement of More Than My Brain Injury. So I'll be doing a series of videos about what is our brain, how does it work, what happens after a brain injury, and how does the brain heal or maybe not heal as well as we think, and why does it not heal all the way? And how can professionals help individuals who have had a brain injury regain their independence? So I'll be talking about occupational therapy, different services such as your national and local brain injury networks, speech therapists, physical therapists. We'll get to all of that. But today, what I thought would be important is to talk about the brain and how can we understand the brain on a more basic or general term or way. And the way I really like to explain the brain is like a house. And so I think of the skull, our skull, as the makeup or the wood structure of your home. It's strong, it's sturdy, it's meant to protect the inside of that house from hail, wind, cold, tornadoes, and it's supposed to withstand a lot of things. It doesn't withstand everything. And that's the same with our skull. It can withstand bumping your head, falling down on the ground, hitting it on concrete, but sometimes there's damage to that. But in the healthy sense of a typically developed brain in our body, the skull is our protective mechanism, just like the walls of a house. When we look inside the walls of that house, we have insulation, which is a second barrier or second protection from the outside world. And I like to think of this as our blood-brain barrier. The blood-brain barrier helps keep out little tiny particles and things that is not good or healthy for our brain's function to keep it running at its peak performance. And so the blood-brain barrier to me is like the insulation of our home. What else serves our house? Our plumbing. We have plumbing, and that brings water throughout your home to different rooms, and it takes out wasteful or dirty water. It brings in fresh water. This is our vessel system or our blood vessels, okay? So our blood flow to our brain. We have little vessels and arteries within our brain that help feed our brain oxygen, but it also takes out things that our brain doesn't need to optimally run. And finally, our electrical system, and that's what I'm going to touch on today. So our electrical system in our home runs everything. It powers your television, it charges your phone. It does major things like keep your refrigerator at a certain temperature, which is a constant job. It powers your air conditioning system or your heating system. It has thermostats that help to regulate that temperature and know when your fridge is getting too warm or your fridge is getting too cold. It's always running a little, but it really kicks in when it hits those endpoints that you need a little extra juice from the electricity to either cool your fridge off or bring it down. Same with your air conditioning and your heat. Those are big proponents. They take a lot of energy from our home to make sure that our temperature in our house stays consistent and comfortable. But we also have little things like our lamps, our light switches. There's one behind me on the wall. When we turn that on, then the electricity comes in and it does a job, a smaller job. It turns on the light bulb. We have that same component in our body to move my fingers, to wiggle my toes. It's not the biggest job my body has. Some of the biggest jobs my body has is making my heart beat, making my lungs move, helping them to do those things, regulating my body temperature, keeping me in upright posture, being able to see and interpret what I'm seeing, being able to talk. Those are some of those major components of my brain and that nervous system of my brain. So our brain is electrical. It is. It's very electrical. It has billions of little tiny electrical systems called neurons. And so I'm just going to briefly share that with you guys today and then talk more about this at a different time and what happens when those are damaged. So here's kind of my first grade drawing of a neuron, but I just wanted to give you an idea of what that looks like. So our neuron is made up of 4 major parts. Okay, we have dendrites, and dendrites bring in information. They're going to bring in information out in our brain. Okay, so we have billions of these little neurons floating around in there, but there's just some space, and there's these different things out there, whether they're neurotransmitters, they may be different chemicals, and they attach to those dendrites, and the dendrite sends that into our cell body. And our cell body is like a miniature brain within that neuron, and it decides the importance or what those chemicals coming in are telling it to do. If it tells it, I'm coming in, but I don't need anything from you, then that neuron's just gonna chill. It's not gonna complete its process. But if the energy comes in there and it says, we gotta do something, we need to walk, we need to get up and make a cup of coffee, that neuron is going to send a signal, okay, an electrical signal down this axon. This axon is going to get down to the end here with all that electrical signal, positive or negative, and it's going to release neurotransmitters back out into that space in our brain, saying, hey, I need to send this information on. So that information leaves the end of that neuron and it attaches to another neuron, and the system continues, and it continues in our brain. It goes to different parts of our brain, and it goes out into our body through our nerves. And that is what keeps my heart beating, or allows me to grab that cup of coffee to be able to have a nice treat in the morning. So the little things that make up or that help with that electrical signaling are your sodium, your potassium, your chloride, and then at the end here we have some calcium. But those are positively or negatively charged, and that is what makes our brain send out signals or information. Okay. There's another little component to that. So that's the nervous system of our brain, is all these little neurons. In our brain, the neurons are what are doing things. When it gets outside of our central nervous system or outside of our brain or our spinal cord, then it becomes our nerves. And that's the things that help us to actually fire or move our appendices or flex our muscles or things like that. But the component that I really want to talk about is, what are those neurons doing? Are they always turned on? Are they always turned off? Is every single neuron in our body on all the time? Do they wear out? What happens? Well, they're not all turned on all the time. Just like in your house, you don't have every light on and every appliance on and every cell phone plugged in and every computer on, because that would eat up a lot of energy and a lot of electricity, and that would be one big electrical bill. But we don't do that because it's not necessary. It's wasteful. And our body's the same way. It doesn't want to waste energy. So it says, only turn on what we need and when we need it. Okay. So some of those bigger proponents, like our refrigerator in our house, that has to be on all the time. We can't turn it on and then turn it off and then turn it on and turn it off, right? It's too many important things in there, all of our food. And we want to make sure that it also understands turn on at this point and turn off at this point. So when it's this warm in that fridge, turn on, cool it down to this point, and then just take a break. It's very efficient. And our brain is very efficient that way too. So it will turn on neurons and large amount of neurons at the perfect amount of time. So to keep me being able to breathe, to keep me regulating my temperature, those neurons are on all the time doing a job. But my neuron to remember neuroanatomy or to remember certain things, those aren't always firing. Those turn on when I need them. And when I'm wanting to learn something new, those neurons are going to turn on. Or when I'm going to use my hands or use my legs, then those neurons are going to fire a signal. But otherwise, they're just off hanging out. We also have a reserve, like a generator, of neurons in our brain that aren't turned on unless we need them. They are just there hanging out, and they're there in case the supply and demand, we need the demand. And so there's a supply of extra neurons that hopefully can get in there and help out should we need them. All right. So I hope that kind of helps you understand how our brain works. And so an efficient brain is going to have all of these systems under check, under lock and key. They're going to have the perfect ones on when they need to be on, ones off when they need to be off. And if we need certain ones, have the ability to send a signal to turn them on when we need them. So if we're looking at that, that's an efficient brain makeup. Our house is efficient when we have good protection, okay, our skull, when we have that extra layer of finite protection, our blood-brain barrier, okay, that's the insulation in our house. We have a good blood flow coming to our brain, our plumbing system, okay? We don't want any clogged pipes because that can cause damage. So our blood flow is good. And then that huge component of our electrical system and helping our body and our brain to function and retain information and keep me breathing and smiling and talking to you at a correct rate and in the most efficient way. So that is how our brain functions to help us, and it helps us to grow and retain memories and be able to learn new skills. So we're gonna end there. Neurons, important electrical system. Our skull, important for protecting that network. Our blood-brain barrier, important for insulating and helping to keep little tiny things out and protecting. And then our plumbing or our blood flow through our brain. So those are the main components of our healthy brain. And we're going to talk about next time what happens when there's damage to any one of those systems and how that can impact the efficiency of your home or your body's ability to perform things in your daily lives. Have a great day, and we'll see you again soon.